All right, let's talk about wave speed, and especially its relationship to frequency and wavelength. That's really the most important thing that you'll see in these types of problems in introductory physics. All right, now, the motion of a wave, since the wave is just something that's created by a disturbance and then just propagates of its own volition through the medium, the motion of the wave depends only on the properties of the medium itself. And that means that its speed can depend only on the medium. But that doesn't mean that it's independent of the wavelength and the period. It does depend on the wavelength and the period. Just through this standard formula, speed is equal to distance divided by time. Now, if I've got a periodic wave that's propagating through a medium, how far does it go? Well, if I'm talking about one of the disturbances, then the distance is equal to the wavelength. How long does it take? Well, if I'm talking about one of the disturbances, the time is equal to the period. And that means that speed equals wavelength divided by period. Now, we can write this in a form that's more commonly seen just by taking this factor of lambda out and remembering that 1 over the period is equal to the frequency. So that means speed equals wavelength times frequency. This equation is extremely common. You'll see it all the time in this unit in physics. All right, so let's see what this means. If I'm talking about waves propagating through the same medium, then the speed got to be constant. That means that the wavelength times the frequency is constant. So that means that if the wavelength goes up, the frequency got to go down. Conversely, if the wavelength goes down, then the frequency will go up. So long wavelength waves have very, very, very small frequencies, whereas short wavelength waves oscillate very fast and they got high frequencies. All right, let's see how we can use this idea to solve some problems. The procedure is fairly simple, but I wanted to illustrate a couple of the common mistakes that people make. All right, so number one, very straightforward. A wave has a wavelength of 2 centimeters and a frequency of 300 hertz. What's its speed? Well, v equal lambda f. So I'm going to say, all right, well, v equal lambda f. So lambda is 2 centimeters. F is 300 hertz. So when I multiply 2 by 300, I get 600. But now what's the unit? All right, well, if I just do this directly, it'll be centimeters. Hertz is waves per second, so this will be per second. But of course, that's not SI. What I really should do is I should absorb this 100 into the centi and write the answer as 6 meters per second. And if I do that, no problem at all. If I don't remember to do that and it's a free response problem, I'm fine. As long as I wrote it as centimeters per second, it's not wrong. It's totally right. But if it's a multiple choice problem, chances are the answer is going to be given like that. And I got to be able to recognize that. All right, problem 2. A wave propagates through a medium with a wavelength of 20 millimeters. So now I want to know, what's the wavelength of a wave that has twice the frequency? All right. Now, I don't know what the speed is here, so I can't get the frequency. So, but the thing is, I don't need to, because I know that wavelength times frequency is constant. So, I'm multiplying the frequency by 2. So what does that mean about the wavelength? Well, if the product's constant and I got a 2 here, I got to have a half here. So I'm going to multiply the wavelength by a half, and a half of 20, 10. So there it goes. All right, now the idea is I didn't have to have numbers for everything. Often problems are given in that way in units like this. And so you just have to know how to set it up. It's not difficult, but you just have to know how to do it, and it just takes some practice. All right, so let's look at the last one. A wave with a 21 millimeter wavelength moves into a medium with 1/3 the wave speed. All right, now something's going on here. We're not in the same medium anymore. All right, now we got to keep something in mind when we go into a different medium. Frequency can't change. Neither can period. Everything else, all bets are off. Frequency and period gotta remain the same. As long as it's the same wave, frequency and period are the same. Everything else can change. All right? So, goes into a medium with 1/3 the wave speed, and I want to know the new wavelength. All right, here's the idea. Speed equal wavelength times frequency. We said frequency can't change. The speed went down by a factor of 3. The frequency is the same. Can't change. So what does that mean about the wavelength? Well, it means the wavelength's got to go down by a factor of 3 because the wavelength is allowed to change. So as soon as we recognize that, the problem becomes easy. 21 divided by 3 is 7. And we're done. But we need to understand that simple fact. And I've seen a lot of problems that are written even easier than this, where it'll say, what's the new frequency? It'll give us frequencies instead. Or does the frequency go up, go down, or remain the same? The frequency got to remain the same because frequency can't change. And as soon as we recognize that, and that this equation is always true, wavelength and speed got to do the same thing. All right, that's wave speed.